Alright, so I wanted to make another video just to address this business about the rationalising of the denominator, because this is something that you'll need to develop and take forward with you as you go into Maths 1. So the basic idea is that if we have a radical on the bottom that's algebraic in nature, and the rationalising process says, well, how do I remove that? And the way is we square it. We would do a square. And the way that we would do a square is we have the denominators multiply, and that has the effect of squaring a square root. And so the maths of that is that we will have a to the half times 2, and we know that they multiplied gives us a1 on the denominator. So we've effectively removed the we've effectively moved the radical from the denominator. Now on the top of, now we can't just willy-nilly multiply it, so we'll multiply it by 1. There's our favourite friend again. That's a form of 1. So according to that 1 times table, we're not changing this quantity at all. So all we'll get is the radical on the numerator, and so it will remain. So this process of squaring the denominator is called rationalising. Rationalising the denominator. That is to take the irrational out. Now we don't. So this is something that we'll. It's a nuance, but it's an important nuance. It will come up, so that's why I'm making a separate video to address it. So that's the basic concept. What happens when we get something that we don't recognise, that this rule, which completely explains what to do, isn't recognisable? So the example that we've got over here is the root 5 minus the root 6. Now at a first glance it would seem that simply multiplying by some radical isn't going to work. So there's a special form, and the special form of a denominator that's got multiple terms is called let me just write that out, a denominator with some terms, summed or subtracted, doesn't matter, is called the conjugate. Now you'll learn about conjugates in 4-unit maths when you do complex numbers, but here it's just a way of just helping you understand that we're multiplying by 1, but we're going to multiply by a special form, and the special form is that we change to the opposite sign and what you do to the bottom, because we're going to multiply by 1. So there's a really unique form of 1, isn't it? That's a really unique form of 1. So we're not changing this at all. It remains fixed. So that's good. Now, what we'll recognise, of course, is that 1 times the top is just root 5 plus root 6. That's fairly straightforward. But the bottom has brackets we're going to introduce now. Okay, root 5 minus root 6. Root 5 minus root 6. And so we'll have to do our FOIL expansion across all of that to get that out. So 1 times the bracket plus root 6 is just root 5 and root 6. Okay, so just that, keeping that numerator simple. On the bottom here, we're going to get root 5 times root 5 is root 5 squared. So that's going to undo. Then we're going to have root 5 times minus root 6, so that's going to be a product. Root 5 root 6. Then we're going to have, so that was minus. Then we're going to have minus root 6 minus root 5. And then finally we'll have minus root 6 times minus root 6, which will be plus root 6 squared. Very good. So, whew, pretty long-winded just to get that first part out. Okay, so the next thing then is what we'll have. These are clear. The maths of this is that the half times the 2 will give a 5 on the denominator, and that will give a 6 on the denominator. These guys here can be now combined because they're a product. Okay, so what we'll have under there, I'll just put it over here again. Oh, sorry, wrote 5 plus root 6 on the numerator. So this term here just becomes 5. This back term becomes 6. And these guys become minus 5 times 6. I'm being the long way teacher. Minus 5 times 6. I've joined them together in the middle, you see? And that's plus 6. Okay, so 5 and 6 is 11. So we'll put the plus 11 down the back here. And then what have we got? 5 5s are 25, 30. So we've got minus root 30 minus root 30. Okay. Okay, so I put a minus on there. Sorry, the plus, that should be a plus, so I do beg your pardon. So that should be a plus. Now what we find is that I didn't need to continue the expansion, but basically an apple minus an apple is going to eliminate. So we end up by completing the sum as root 5 plus root 6 over 11. So we've rationalised. We've taken the numbers off the denominator. So it's a little bit complicated, but just be careful of that plus 1, that plus and minus. So in effect, that's like a difference of 2 squares, and it eliminates the terms, and you're just left with the square terms. That's another way of viewing it. Let's do another example just to help that out. So we've got root 3 plus 2 divided by root 5 plus root 3. Now we don't want to change the quantity at all, so we're going to multiply by a version of 1, and the version of 1 that we're going to use is the conjugate version. So root 5 minus root 3. So that's 1 in disguise. That won't change. So we'll have a product up the top that we'll have to deal with, and a product down the bottom. Alright, so on the denominator we will have root 5 plus root 3 multiplied by root 5 minus root 3. Okay, and up the top we'll have a similar thing, root 3 plus 2 multiplied by root 5 minus root 3. But I'm more interested in the bottom. Okay, now when we do the expansion on the denominator, we'll get root 5 times root 5, so that's that one, is root 5 squared, which is just 5. Notice that it's not 25 or anything like that, it's just the number. Okay, then we'll have the FOIL first, so we're doing FOIL expansion. So the outside pair will have minus root 5 root 3 as a product. Then the inside pair we're going to have plus root 5 root 3. So those two guys are cancelling, and then finally we'll have minus root 3 squared. And minus root 3 squared is going to be 3. So what's happened here in the denominator is that this minus an apple plus an apple, they have cancelled. So 5 minus 3 is going to leave you with 2. And on the top we can, now that's the rationalising process. That's what we're really interested in. The rest of it is just some gymnastics. So root 3 times root 5. Root 3 times minus root 3 is going to be minus root 3 squared, which is just minus 3. Then we've got 2 root 5 and 2 root minus 2 root 3. Okay, so that's the numerator. What can we do with anything there? Root 3. So we could add that together. So root 2 root 5 and root 3. They're root 15. It's just not going to be pretty any way we look at it. I don't think we want to add 2 to root 3 because that will be, well, why not? We can do 2 plus root 3 times root 5. That's an awkward way of dealing with that sum. Then we've got minus 2 root 3 and minus 3, and I think that's pretty much how we'll leave it. Now you can process the numbers as numbers, but essentially that's going to be left pretty much like that. So we can do our values, but you can see that we've rationalised the denominator. Alright, let's do another example. 4 root 5 plus root 11, and we've got 2 root 5 minus root 3. So we don't want to change this, but we're going to be a conjugate. So we're going to have 2 root 5 plus root 3 divided by 2 root 5 plus root 3. So this is a form of 1 that serves the purpose of not changing the quantity, but at the same time rationalises the denominator. So if we take the numerator, we'll get 4 root 5 times 2 root 5. That's that part. Then the next part's the outside. So we're going to have plus 4 root 5 times root 3. Then we're going to have plus 2 root 5 times root 11. And the final outside one is root 11 times root 3. Okay, and that's not important. What's important is this part. 2 root 5 times 2 root 5 squared. The root 5s are going to disappear. The 2 times 2 will be 4, and so 4 times 5. 2 times 2 and 4 times 5. So we still have to deal with the numbers. Now the outside one will give us minus root 3 squared. So that's that expansion there, minus root 3 squared, which is minus 3. Then we'll do the inside pair. Sorry, I put that together that way. I should have said it differently. Okay, it's got to be a little bit tricky. Just getting back to, that's why I did this as a separate video. 2 root 5 times root 3 plus 2 root 5 times root 3 as a product, but then we've got minus root 3 to root 5. So this and this one are plus an apple and minus an apple. Very hard to see in its form. And then the final one is minus root 3 plus root 3, which will give us minus 3. So on the denominator, we've got 20 minus 3, which is 17. And then we've got all of that stuff on the top. Okay, so we've got 8 root 5 plus 4. Sorry, we're multiplying them, so I need to eliminate those. So we've rationalised the denominator. So it'll be 8 times 5, which is 40. For this term here, it's 4 times 3, which is 12. Okay, these are different. Oh no, that's root 3, sorry, I've made a mistake there, I better fix that. Yes, you've got to be very careful, haven't you? Very careful indeed. So just write them out. If you're not sure, just write them out. We've rationalised the denominator. I don't like exercises that have got this kind of, it's very distracting for students. I just don't see the value in it. 4 root 5 root 3. I'm going to leave that for the moment because that'll be 4 root 15, so I'm going to do it that way. 3 5s are 15. For this one it'll be 2 root 55, and this one here will be 2 root, what's that one? 4 root 5 times root 3. Root 11 times root 3. So it'll be root 33. Yeah, they're all positives. So you can, I'll leave you to think about how that might be simplified on the top. But they're numbers, so they can be processed with a calculator. Alright, so rationalising the denominator, it falls out fairly readily. Some of these are a little bit annoying in the way that they do that. I'm not sure how representative that is as the problem solving model that we want, and in the future I might change those to represent something more realistic. Alright, so let's have a go at 7. Let's have a go at 7a. So we've got 5 root 3 plus root 7 divided by root 7 plus root 3. So these are obviously a little bit simpler. So we're going to not change the quantity by multiplying by 1, and the form of 1 will be in this conjugate form. That is, we're changing the symbol to minus. Okay, so what this will have an effect on the bottom is that root 7 times root 7 is root 7 squared, minus root 7 root 3 plus root 7 root 3 is cancelled, and then we're left with, so let me do that as a whole. So that's that one. First, outside is minus root 3 root 3, and then inside so outside first, outside 7, and then inside is plus root 3 root 7, and then the final one is minus root 3 squared, which will be just minus 3. So these are minus apples and plus apples, so we've managed to rationalise 7 minus 3. The denominator has 4 on the bottom. So that's the purpose of the rationalising of the denominator. So that's fairly straightforward. What I'll do is I'll just bring this down a little bit because I want to see one more thing. That's it. I wanted to check my answers. Okay, so we might just keep going with that one in its simplification, just to verify that. Alright, so then at the top we've got 5 root 3 times root 7 times root 7. Then the next term, that was that one, and then the outside is minus root 3 times 5 root 3. Then the inside is root 7 squared, so it's just going to be plus 7, and then root 7 times minus root 3. I think that's right. Okay, so square root of, so 5 root 21, 3 3s are 9, root 3 squared, so it's just 5 3, so minus 15, plus 7, and the square root of 21. Okay, so 15 and 7. 15 and 7 is minus 8. So we've got minus 8. Now 5 apples minus an apple will leave us with 4 apples. So 4 root 21 divided by 4. So we can look at this one at the top on the numerator and say what's common to those two. what's common is 4. 4 exists in both of those, so we can take 4 out. So we've got root 21 minus 2, and on the bottom we've got 4. They will cancel, and so we'll be left with root 21 minus 2. And if all's gone well, which I'm hoping it has, we'll see that that's root 21 minus 2. So we'll give ourselves a little tick. Alright, so just using, these are the hardest things that you'll do, these 30 things. I did that in the previous example when I made that for you. So that's quite tricky. I'm going to keep going with these because Wolfram doesn't like the surds so much. So I'm just going to keep going with this. 5 root 3. We'll get the concept in hand, and then if it turns up in Pearson, we'll be on top of it. So we're not going to change this fundamentally. We're going to use this idea of a conjugate. We're multiplying by 1. We're invoking the 1 rule. So we're not changing this term at all. It's just a very extraordinary looking one, and that's okay. It's allowed to be. So then what we'll do is we'll go and do our expansions. 5 root 3 times root 7. 5 root 3 times root 7. That's our top one. So I'm just doing it on the top. That's that one. And so on and so forth. I'll stop drawing on those now. So we've got 5 root 3 times root 3. So we're plussing 5 root 3 times root 3. Then the next one is root 7 squared, which is just 7. And root 7 times root 3. So we'll just put that in there as root 7 times root 3. So that's our numerator. We'll get to the numbers of that. Now on the bottom, our expansion is going to be like the normal FOIL. So I'm deliberately not writing it to make you think about what the FOIL will look like. So the first one will be root 7 squared, which is just 7. Now we'll get plus root 3 root 7. Then we'll get minus root 3 with the inside one. And then we'll get minus root 3 squared, which will be minus 3. So these are apples, they're gone. So we've rationalised the denominator, so we've been quite clever in that. Okay, 7 minus 3 is 4. Alright, up the top, these are products, and we can take the maths of those is we can take the root 3 and the root 7 and we can put them in as 3 times 7, so that's why I'm just doing it number-wise. So 1 out the front, 5 ones are 5, and root 21. Same here, number out the front. Oh, root 3 squared. Root 3 squared is 3. 3 times 5 is 15. So that was just a rationalising thing happening. Plus 7, that was unexpected. Root 3, so it's root 21. Alright, so 15 and 7 now is 22. And an apple plus an apple is 6 apples. So we've got 22 plus 6 root 21 over 4. And if we check that out, we'll see that we're pretty close. And the only thing that's happened is the 6 root. Oh, it's 2. 2's come out. 2 and 11, of course. Alright, well, there you go. Okay, so what's common across the 22 and the 6 is 2. So if we take the 2 out the front, then we would need 11 and 3 root 21. That doesn't change that bit. And on the bottom we have 4. So that will cancel, and that will become a 2. And if I put it the way the answer's got it, it's got 321 plus 11 over 2. I think that's how it's written. 3 root 21 plus 11. So there you go. That's fairly straightforward. It's an important nuance. Okay, so there's a lot there. It's an important nuance. So it's important that we understand that it's advanced work. It's advanced gymnastics. So I've included it. All right. So 5 187 plus 15. Oh, wait a minute, mate. That's not the question. Erase that because that's your answer. So put that back to there. doing 5 root 11 over root 17 minus 3, and it doesn't matter that it's got the third. We're not going to change the value, so we'll do the conjugate and root 17 plus 3. So we're not changing the term, we're multiplying it by 1, we're just multiplying it by the conjugate. So if we do the top, we'll get 5 root 11 times root 17. Added to that, we'll get 5 root 11 times 3. So that's the top expansion. So that's 1, 2. So that's why there's only 2 terms. On the bottom, root 17 squared is 17. Then we'll have plus 3 root 17 and minus 3 root 17. Minus 3 times plus 3 is minus 9. They're apples, and minus an apple. So on the bottom we'll get 17 minus 9, which is 8. And up the top here we'll get 5 times 1 is 5. 5 root 77. Oh no, 11 17s. 7 1s are 7. 1 1's a 1. 7 1's a 7. What am I doing here? 7 1's a 7. 1 1's a 1. Put out a naught. 7 and 1. 7 8 1. So 187. And for this one here, 15 root 11. Okay, 15 root 11. And how far off are we there? That's it. That's all you can do. There's no more simplifying, so that remains the answer. Okay. All right. So it's just making a different video just to help you understand what's happening with rationalising the denominators, and I hope that served that purpose. Thank you.